Hey guys, the universe is a cruel mistress. Sometimes it gives you alcohol to poison you and try to set you back. That's for me today. Somebody gave me some alcohol that I was drinking in a social setting, which makes you more inclined to drink it. Not this, by the way. I'm just drinking water now. But anyway, so the universe feeds you alcohol. That's poison. That probably kills you. So I'm going to feed the universe Warsmash to get back at it. And that gave me an idea. Okay, and I really don't know if this idea is totally going to work or not, but it's, I think, fairly straightforward. Okay, and my straightforward idea is that LibGDX is a game engine. Okay, and we can stick it to the world by just making a game. And you know, the evil Illuminatis that run the world, or whatever you want to believe in, they don't really want you to believe that what I'm about to do is possible. So let me just do it. So there's this concept of a Warsmash multi-screen game. I'm not even sure we use that. What do we actually use? You know, that's a good question. Yeah, I guess I do. So we could probably leave this as Warsmash multi-screen game, I guess. Maybe we'll just make it a screen. That way you could have a menu later. But my goal is basically to start off with some basic LibGDX stuff here, right? So, I mean, let's call this like, I don't know, fun game. Okay, and it's it's gonna be whatever this kind of thing is here. What is this? Screen. Yeah, it implements screen from LibGDX. It's like a screen of a game. They already built this whole game library, guys. Come on. It's not really that hard. So this can be a screen that I have. And, you know, by default, what is a screen? Let's set my screen. Let's get this new screen called Fun Game. Let's actually call it Fun Game Screen. That makes sense. So now I have a Fun Game screen. What are we going to do with it? Well, in Desktop Launcher, the existing Warsmash creates this multi-screen game, and then it does all this complex stuff. I'm going to say if false. I'm not going to do any of that. And then how about we just say Warsmash multi-screen game thing, set screen to new fun game screen. Awesome. And you know what this will probably do? I know what this will probably do. I bet that, sorry, I clicked the wrong button up there on the top of the toolbar. This will probably give us a black window on the screen that's just blank. I guess it might be full screen so you can't see anything. So that's kind of dumb. So let's make it that it's not full screen, to be honest. Let's make it windowed. And I think this will still honor the Warsmash window program argument. So I'm going to run that. And now I think it'll be windowed on the screen. That's great. But as you can see, it's solid black. You know, this is like an empty canvas going on here. So then you get back to what can you do in Fun Game Screen? And I guess that gets back to some of the key things. So in Fun Game Screen, when we create it, let's make a constructor for creating this screen. I want an MDX viewer. And this gets back to the design of Warsmash, the history of Warsmash, and why it's so easy to make a new Warsmash for you today. The history of Warsmash is to just copy Ghost Wolf. Okay, this isn't innovation. I just wanted to show off. Because I wanted freedom and Warcraft. So we can make an MDX viewer from Ghost Wolf, but we're gonna need a data source, and we're gonna need canvas provider. And we're going to need default lighting. So we got to get those three things. The data source, the outside, I think, could give us probably, maybe. But to be honest, why think hard if you have the option of not really thinking that hard? We can just copy this stuff from Warsmash menu screen. So then you get back to where, what does that one do? That doesn't take in a data source. It takes in a data table, the INI file of Warsmash. So it's just going to build its data source from that same INI file. That seems simple enough. There's probably a function call that does it. Let's look at that. Here you go, Warsmash screen parse data source, whatever. That's a great function call. So we do want to copy that one. These are those few things that aren't copied from Ghost Wolf that are stupid Warsmashisms, like the concept of a data source. It's literally just a Red Rum Model Studio data source. I just copied it over. Okay, it's all a big copy paste done in a hurry. So this was wanting to call itself codebase, but let's call it data source to be consistent. So this is our data source. We're going to put the data source into an MDX viewer. Okay, so that's great. But what else do we need to give this thing? You'll notice it has a canvas. And so actually, it looks like I'm copying from another MDX viewer, and I'm kind of liking what I'm seeing. So you'll notice that apparently the multi-screen game itself was a canvas provider. You might have seen that go by earlier in the video. So if I just pass that one in just the same, we're going to have the game in here. We're going to have the MDX viewer. So I think that's pretty cool. Now, this MDX viewer should probably be a field on this class. So I'm going to auto-convert that. But is this even sending to you guys? Yeah, you can see what I'm doing. Okay, great. So I've got this MDX viewer. Let's view an MDX. What are we going to put on the screen? What should it be? Probably one of the hardest things is camera, to be honest. But let's not worry about that yet. Desktop launcher. You'll notice everybody here wants to INI on the game screen. And now our fun game screen is just the same way. So I'd say we're making excellent progress. But we might also want to say in how this thing runs. What are we going to do in this viewer? And the truth is, we do have to have a scene. So I'm just going to copy this stuff. This is pretty smart. Yeah, fun game screen. So our viewer is going to, let's see. Yeah, basically we want to call add handler on it. And we want to enable audio. So add handler, this tells it can parse MDX files. That's kind of dumb that that's necessary, but we're going to do it. Once you have a viewer, you want your viewer to create a scene. And that's useful so that you can render things in the scene. So now I have a scene, now I have a viewer. I guess the scene has to enable audio, which is kind of dumb. But I like audio, so we'll go ahead and just do that. And then, see some inconsistencies up there. Basically, the scene gets created, blah, 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 blah. We create a scene, and then we have this like resize function that tries to handle maybe scene update or something. I think. Maybe not. So I was trying to remember, when we render the scene, how does that actually look? And for the most part, you don't have to worry about that because we can just say when we're rendering that we're going to update and render the thing. So a bunch of code just went on the screen. I'm not copying all that code we just saw. I'm just going to say MDX viewer update and render. And so I'm going to update and render in the render method of our world. So that seems pretty good. Let's like add an MDX or something. Because I feel like we want that, like we want like MDX viewer dot load units human phoenix dot MDX. Like, wouldn't it be cool to have a phoenix on the screen? I don't know. The path solver is always dumb. Just, you can get the path solver of our guy. And then mdx viewer.solver params. Yeah, so those are some holdovers from the port of Ghostwolf that are kind of stupid. This should load an MDX model, but instead it loads a resource. So we have to do a cast, and that's kind of gross. But we know it's an MDX model that we're loading. So I load this MDX model of the Phoenix, and then I'm going to say add an instance to the world. So this is my Phoenix model instance. And that seems nice enough, doesn't it? Sorry, what? I just filled the screen with trash on accident. But yeah, Phoenix model instance is here. That's cool. Let's see how that looks. I don't know if we'll actually see a Phoenix. I highly doubt it. I don't think that works that way. So you'll notice we don't see a Phoenix. And you might ask yourself, why not? Why don't we see a Phoenix? And there's probably a good answer. One of the most important things, usually, is the camera. So I guess you could say, you know, is there a world where we need to worry about that? There were a bunch of complex camera managers. Sorry, I bumped this computer. There were a bunch of complex camera managers in some of the other code, but we don't really need to care about that right now. I'm just hoping we can see the model at all. And to do that, probably, we're going to need to say, oh, here's the other thing. I think we need Phoenix model instance set scene to the scene. So I didn't actually put that model in the scene. So that's an interesting thing. If you think about how you can have a Warcraft model in the game world or in the portrait screen, there is this concept of different scenes, and we have to put the model in the scene. It's almost like kind of overkill, but it makes sense if you think about portraits. So that's probably going to fix it. Maybe that'll make it that we do see a Phoenix now, actually. I kind of just forgot about that. But if we do see a Phoenix, it'll probably be like orange and in the camera flickering or something, because, yeah, it isn't even. Probably because it didn't set its animation. So we need to set its animation sequence to like stand or something. But it goes beyond that, because not only do we want it to do a stand animation, we also want to put the camera where we could really see it, which I didn't really do yet. So I guess that gets back to like mdx viewer.camera. But that's not correct. Sorry, no, the scene has a camera. Scene's camera. I wonder if it updates when the scene updates. Surely updates the scene, and updating the scene updates the scene's camera. Yes, it does. Okay, cool. So all that doesn't matter. So you don't have to update the camera. We just have to tell it where to go. So then we get back to this camera, which we want to basically tell it that that it'll move to and face. So I'm thinking we're going to move to a new, yeah, we use vectors, we use 3-component vectors, location, target, and world up. So these are going to be really straightforward, okay, because the target is going to be the origin. The location is going to be x of 120, and the world up is going to be a vertical vector with z equals 1. So I'm hoping that'll make it we can see this Phoenix, and I kind of still doubt it. I think there's some other work to be done. Namely, I'm not really sure that we called scene.camera.viewport yet. Like, who is calling that? I feel like we need to call that, and I don't understand where that's called, because I forget. Oh, yeah. Okay, so all this temporary rect nonsense that was going on in resize This is some gross boilerplate, and we should probably fix that. But if you look at... What is all that? That's a broken lot of hoopla. Look, I'll tell you what. That looks like a broken lot of hoopla, but I'm just going to copy it for now because I think the concept is sort of reasonable. Where basically I have this rectangle, and I reuse the rectangle. I didn't want to have to create a new one every time the screen moves around. I didn't want to have to create a new rectangle. So I just create one rectangle called the temporary rectangle at the start of the program, and I just keep reusing that rectangle. So that's our temp rectangle, and we're going to set the viewport to it. And what that really means is that when I resize the screen, I'm going to set my viewport to match. And we're going to call that same function on the startup so that I just restart to... what is this? GDX graphics, width and height, the width and height of the game screen? Maybe that's not correct. Maybe it would be more correct to use the canvas provider on startup. I want to say that the other stuff probably does this though. They all just hack together. You can see the original code of Warsmash is not really better than what I'm hacking together right now. There's a lot of commented out trash and that sort of thing. Yeah, it is pretty much doing what I did here. I think it might actually make more sense if we use like the game thing. Although that appears to be the wrong type of value. Sorry, I accidentally hit some help hotkey. So let's see, it's not applicable for floats. So I'm just going to cast this to an integer and maybe it'll stop complaining. Cool, I think that makes sense to me. So I think we're getting really close, but obviously we haven't really fixed the problems yet. Because it still is not really showing anything on the screen. So we're creating this camera that exists and faces the center. And after we do that, it's updating and rendering the camera and the world and all this stuff. But for some reason, what was it? Sequence utils? Random stand sequence. It's supposed to make it play its stand animation. It's this old convenient utility. Oh, it looks like this is supposed to be a complex model instance. And I didn't cast it to that. Cool. So now I can make it play its stand sequence. That's kind of nice. But I still didn't see it. You know, so we're kind of like, why don't I see it? And that's the kind of thing that happens if somebody gives you alcohol. It's like, where's my model on the screen? But I still think we're going to find it. You know? One interesting possibility would be if the file path were wrong on the Phoenix. But I think it would crash. Like if I change it to Phoenix XX instead of Phoenix with 1X, maybe it would crash. I guess not. I guess it didn't crash. That points out that I didn't check the log earlier. So let's check the log. So you can see that it didn't have a problem with the correct Phoenix file path. So I would say it is loading the Phoenix, and that after it's loading the Phoenix, it is somehow not displaying the Phoenix onto the screen. So that's a little bit interesting. One possibility, I guess, might be this vector3.0, because I think this is the lighting. So I wonder, can I do vector3.1? Nope, they don't have that. Okay, new vector3, 111. So that would give us some lighting, actually. That's an interesting point. By default, I did not give us any lighting. It seems that the light is not the only problem. Well, here's an idea. As well as being out at a 120x, let's do a 120 height, just in case there is any chance that existing up above and looking down at our 3D model might help us to see it. But I still don't see anything. And so that's kind of one of the problems that you could have with this, is that the initial getting started is always a bit frustrating, because you start to ask yourself, you know, what did I not do that I meant to do that was expected of me in this API? And obviously that raises the question for me, can I make the API actually be better than it is? But in the meantime, while it's not better, it seems like it's worth thinking about trying to improve on that. It's interesting to me that looking back at the initial code of Warsmash while it was being developed and how similar that is to what we're looking at now, I don't really quite see what is going wrong, but it definitely makes you wonder. I guess there's this whole update camera thing that I wasn't doing. But for the most part, that shouldn't be necessary. Maybe this other stuff, there's some fluff, you know, just sort of boilerplate code that you would think shouldn't be necessary, like in render. But I could try copying some of that and just seeing if that makes sense and if that helps explain anything that might have been going wrong. So far it has not, though. One thing I did notice in the other file is that our Phoenix model instance did not have sequence loop mode set to always loop, which could be fun to do that, so that it's just going to always loop our animation that we put it to do as a test once we find it and find out why it's not really rendering on the screen yet. I still find it very interesting that this thing does not doesn't just render, because I don't really think it's very far off from what we want it to be. I imagine it's very close to what we want, and there's just some kind of issue with the viewer and the way that it's presented. It's pretty interesting, because you'd think that this thing would sort of like already be there and already show and stuff, but so far I don't see it. I don't see what was the problem. Oh, it doesn't set the VAO at the top. We have to set the VAO. This dumb stuff. Okay, so that's some dumb boilerplate again. And realistically, I would much prefer that we didn't have to deal with that. But maybe we do. So I'm just going to try putting this at the top of this show method before I do the other stuff that we do. And I was thinking it might help, because it seemed like that was what the code wanted. But I'm probably forgetting something. Oh, hey, look at that. We did it. Now we have a Phoenix. Okay, so this is the world I was trying to get to. And I think pretty quickly you might start to understand why I was trying to see if I could make this happen. Because realistically, by enabling ourselves to have a graphical context where we can render a Warcraft model, even a little bit, and obviously the scaling of this seems off. So that's interesting. Why is that? But the way that that works and the way that that's decided is from that viewport call. So you would think that we could fix it. It also seemed to be lagging pretty badly, and I don't really know exactly why that is, but it's kind of interesting. So this viewport call, this temporary rectangle, like if we just put, what if I just put width and height and then just say, like, that's it. I'm not going to touch X and Y and stuff. I forget if this makes it like idiotly on the corner or if this just makes it work, because like you would think you would just want it to work most of the time. Yeah. So it's just like a view into a space, and we don't have crazy math going on. That seems way better, actually. So now you can see I've got this random phoenix. And this gets back to like what I was thinking it would be cool to accomplish. If you think about looking down from above, like what if we make my phoenix be my controller that I can move back and forth in one of those like space shooter games? And so in order to do that, when we set our camera and we move to in face, I was setting it to look down on the phoenix before, but suppose that we don't exactly want to do that. What if instead I want to look down from above? And so my camera would be at a really big Z value, like 1,000 Z in the sky. And I'm looking down at 0, 0, the center of the world. And my world up is actually the Y coordinate as being up. And if I do that, you would think that I would see my phoenix in the world, but he'd be facing to the right, because all Warcraft models by default face X equals face the positive x-axis. Look at that. See, that's cool. But what I'm actually imagining when I described it is that my phoenix would face vertical. And so that's how my phoenix model instance right here, we should rotate by a quaternion. But see, rotate by a quaternion is dumb because I actually want facing angle. Is that not a thing that I have? Did I not do that? So let's get back to what happens when a render unit changes his facing. What does he actually do? And if you look at the way that he does his facing angle and the way that he figures out all this math, what he ends up doing with it, with the radians and the yaw and the overall facing, is absolutely this idea that it is instance set local rotation. Okay, here we go. So we're going to set the rotation of our Phoenix model in our model viewer with set local rotation. And it does look like I was using a recycled quaternion, but let's, you know what, that's all about trying to make things fast and memory and stuff. Maybe we don't care about speed. What if I'm just trying to get understanding first? Sorry, and then I just hit a hotkey, the wrong hotkey, and popped up some random thing on the screen I didn't need to. But if you look at what I could do now, I could make a new quaternion that is set from axis, and the axis is the unit z-axis, upward. And then the facing angle would be, I want him to turn up vertical. So how much is that? Well, if you think about pi as a half circle, it would be pi over 2 to face upward. So I should be able to say math.pi over 2. And it's going to complain at me because this is not a float, it's a double precision float. So I have to make that a float. That's a kind of dumb thing I have to do. But anyway, the moral of the story is now my Phoenix is going to face upward. And that's kind of cool. Like I create my little 3D context and face my Phoenix upward. And it didn't work. He didn't face upward. And then you have to ask yourself, why didn't he face upward? There could be a lot of things that go into that. It looks like it's actually degrees. So they fooled me. They're like Warcraft. They actually wanted me to type in 90 degrees instead of pi over 2. That was my mistake. Sorry. Now that I type 90 degrees, you can see that my Phoenix looks more how you would expect. So then the other thing that I was thinking you would want to do is basically to say we want an input processor. So let's say GDX.input, and this is where I'm just using LibGDX. This isn't even Warsmash. I didn't even invent this. I'm literally just using LibGDX for like input and stuff. So I'm gonna make this to an input processor. Sorry, which means let the fun game screen be the input processor. And then if I auto-generate the input methods from that, Now we have all these functions for like key up and key down and touch down and touch up. So basically, if I press key down and if key code equals input dot keys dot left, then we're gonna set like basically like the player movement. So like essentially my thought is you're gonna be able to move the player left and right, kind of like Pong or something. So we could even just have like an enum player movement state. I don't know. There's probably a better name for that. Player movement direction that can be left, right, or none. And so then I can make a variable of type player movement direction. Okay, player movement direction, current player movement direction. And this thing by default is going to be none. But if you start moving, if you do that key down equals left, then current player move direction is going to equal left. And it's the very same idea, like if the key code is to the right, then player move direction will equal to the right. And then basically my thought would be, if we do a key up, then in either case, I'm just going to set it back to none. So this gives me the ability to essentially say that the player has some kind of player position. It's going to move back and forth. And yeah, let's just make a vector 2 of that, because it's really just x and y. So player position, if we think about it, is I guess it's like a constant vector. But rather than just starting at the center, I want the player to start down off the screen a little bit. So let's give him like a minus 250 position, and it's just going to be xy. So like x is 0 and y is minus 250, and that's going to be the player position. And then basically, when I'm actually updating the game, there is no update function. A lot of times LibGDX thinks that you would make your own so that you can decide the rate at which it updates and how that relates to the processor clock. In a simple game like what I'm doing, single player, local machine, I don't care about the processor clock. So I'm just going to make this update function that's called it the same as when I render. It's the same as when I do a frame. So this is like a frame update. I guess if you wanted to be really fancy, you could take this delta time thing that was getting played around with, one of those boilerplate codes I copied, and you would just use the delta time. Speaking of boilerplates, we could also eliminate all that other stuff I don't need anymore. Cool. So delta time is like the amount of time that passed between frames. And the idea is like if you want it to kind of match your processor clock, if more time goes by, you could move the units farther and just use delta time as how far they move. So basically what I'm going to do is say, based on the current player movement direction, I'm going to have 3 cases. I'm going to have the case that's left, which in that case, player position dot x is going to minus equal delta time. And you always have to use breaks in case statements because otherwise they do wonky things. Player position dot x is going to increase by delta time if you move to the right, and then if you do none, it's going to do nothing. Then, of course, the more important thing to do is going to be the whole Phoenix instance. So this model instance of a Phoenix wasn't saved to a variable, so we're going to save that to a variable in our game. And then the Phoenix model instance set location can now set player position x, player position y, and 0 as a way to kind of move. And so now it should be interactable to where we can use left and right arrow keys to actually move this little Phoenix like back and forth. And I think it might be working, but it's going horribly slow. So this points out what is the rate the Phoenix moves. And right now, because I'm moving at only delta time, that means 1 unit per second. But actually a unit would be very, very tiny. This is not a unit like a Warcraft 3 unit, but it's like a Warcraft 3 unit of measure. It's not like a combat unit. It's like a unit of measure. And so in the unit of measure, I want 128 per second. That's going to be about the size of a farm per second. So if I hold this for 2 or 3 seconds, the Phoenix should just float off to the left. And I can do the same thing and have the Phoenix just float off to the right. So that's kind of fun. Like I can literally just like, you know, left, right, left. Honestly, it's probably still too slow. Maybe I want to make that a little bit faster. Maybe we want to do 256. So in 1 second, you could span most of the screen or something. And then we probably also should clamp it. So basically, if player position .x is less than negative 400, then player position .x equals negative 400. And then maybe we could do the same for like capping it in the other direction, that if it's actually greater than 400, then we'll just set it equal to 400. So we have this kind of range of 800 units that we can float around in. And outside of that, we won't really be able to move. Cool. So as you can see, my Phoenix stops there. He can't really go past kind of the edge over there. And I don't know if you guys can see it, but on sort of the other side here, whoop. Oh yeah, that's smart. I could just shrink the game, and then you can see the shrunken game. Let's see. Yeah, if I just kind of shrink this down a little bit, put it over here. Yeah, there you go. So I have this Phoenix. I have the arrow key. I can arrow key the Phoenix to the other side of the screen. So that's kind of fun. Now, I don't know. It's like, are we going to have this Phoenix be like a dodger of like rocks or something? I was thinking it'd be fun to have like when I push spacebar that he actually shoots like an energy blast. I thought that would be kind of cool. That's kind of time consuming though. I feel like just arrow key Phoenix is kind of like a fun starting place. So let's just make like dodging rocks, and if a rock hits you, you die or something. That seems like that's way simpler to do. So let's make a rock dodger, because then I don't have to figure out missiles probably. I don't know, maybe we could do missiles, but for the most part, so you saw there was this concept of a model instance in the Phoenix, and I just hacked into the game this concept of the player Phoenix pawn that moves back and forth or whatever. Realistically, we probably want to wrap things in like a class. It's a pretty standard thing to do in Java, and have what we call a class, which defines a type. So I'm going to make a class called incoming rock, and incoming rocks are the things that you have to dodge. And incoming rocks will have a model instance that is the rock model instance. Like, I don't know, what else do you call this? Maybe even just model instance of the rock. Like, literally just, it represents their 3D presence in the world. And then I think we're also going to have a vector 2 that is just rock position. And this is a rock, so I guess it's just called position. So it has a position, and it has a model that we're going to put at that position to show it. And then, yeah, that's probably it for now. So let's just do that. I guess we could have rocks of varying speeds. So maybe we could have like a floating point value for the speed of the incoming rock. Once you have something like what I just did here in Java, where I just defined a class, you can use hotkeys to automatically generate the constructor calls for that. So it'll automatically know how to create an incoming rock for you if you want to do that. Just say new incoming rock. The other thing I like to do maybe when I'm making something like incoming rocks would be to make like a list of incoming rocks that represents all of the incoming rocks in the game. That seems like that makes sense to me. So I have this list of incoming rocks. That's going to be all the incoming rocks in the game. I just use the hotkey to automatically include the concept of list, because, you know, why didn't we even already have that? That's silly. I would say when we update, why don't we have like a constant factor, a constant time or something, total time maybe, that is going to be constantly increasing. So basically, whenever we update, total time increases by delta time, that time that had passed between frames. And that's where we could say like, okay, so the time, we're kind of just keeping track of how much time has passed. And then we could say like when the time is more than a certain amount. So like if total time is greater than 1 second, then total time minus, basically it reduces by 1 second, you know, minus equals, reduce it by that 1 second. So essentially, like whenever it's been a second or so, then we'll count it down. And in those seconds, as those pass, I'm going to do incoming rocks.add new incoming rock. And this is going to be something, the sort of the hard part here is going to be figuring out the incoming rocks position and such. As far as where to put it, yeah, it doesn't seem to want to autofill for me today. But I would say, first off, I'm going to make all the rocks have a speed. I was going to do 256, but let's do 512. And they're going to have a vector 2 of where they are. And so for that, I think the y coordinate of where they are needs to be whatever is our max y. Like, what is that? 512 off the screen? 500? Maybe 500y. But what is the x coordinate? The x coordinate could be like a random number. So we're going to be randomly on the top of the screen somewhere. So for that, we want a range of negative 500 to 500. So we should be able to say math random times 1,000 minus 500. So that basically defines that. It is probably going to tell me this needs to be a floating point, not a double precision floating point. But again, I guess the hardest part is going to be the model instance of the incoming rock. And I'm not quite sure. I guess, yeah, I needed to make sure that thing was a floating point too. Okay. So one thing we did at the start is we loaded this MDX model that is the Phoenix model, really. I hadn't named the variable, but it was the Phoenix model that I loaded. What I need to also do is basically load, because there's two concepts. There's the idea of a Phoenix. You can have 1,200 Phoenixes in the world, but you only want to load the file of the Phoenix one time. So that's the Phoenix model that you load one time. And the 1,200 Phoenixes in the world, those are the Phoenix model instances. So I'm just going to do the same thing with the rocks. And I basically just want to have, what do you guys think? Can I remember this? What is it? Abilities. Abilities. Have I had too much to drink? Weapons. Ancient Protector Missile. Ancient Protector Missile. I think that's what that is. We'll see. So this is going to be the rock model. That's my point. And we'll save the rock model to a variable. And that way, when I actually create a new rock, incoming rock.add, I can actually say rock model.add instance, and it'll be this model instance. It's a rock model. Sorry, I deleted where I said rock model there. So I guess the other problem with that is not putting it into the scene like we would want, because we do sort of want to be able to take this model instance and actually put it into the scene. So that points out, that was something I forgot last time. We're going to set scene to the scene. The only scene that we're using is the scene of our game. So I have this rock model instance, and I put it in the scene of the game world. And that's great. But now what? Now will we see it? Will we actually see the incoming rock? And I think realistically that we probably will not, because there's a couple things going on here. But first off, there is this concept of the vector that represents the position of this incoming rock. But basically, let's call it the rock. I think that rock should have like a rock.update method, and we're going to have to call that in updates as well as when it's created. So basically, when a rock updates, the idea is going to be that we're going to take its position, and we're going to take the y value of that, and we're going to subtract its speed times, I guess it should probably pass in the delta time to the update so that we know how much time has passed. So the speed of the rock will be per second. We multiply it by a delta time by per second. So the rocks are all moving southward. But they're changing the position, the stored position of the rock doesn't really matter unless I also take the model instance of the rock and do set location to position.x and position.y and a 0 height or on a flat plane. So that's the concept of how to update a rock based off of delta time. Or even, I think the first update would be 0 because it's just when it's created. But after that, we also want to say for every incoming rock in the incoming rocks, let's rock.update. So that every like frame and stuff, we're updating these rocks. So the rocks can't hit us yet. Like we didn't program in collision. But I think from what we just did, we might actually see the rocks, which would be kind of fun to kind of see oncoming rocks. Oh, I see one there, but it's not moving yet. So it looks like we still have some work to do. Yeah. So the rocks appear to be stuck in place. They're not really moving yet. They appear to be sitting kind of randomly and not really moving. So that's interesting. Why are they not moving? One thing that did occur to me actually is I never set the rotation of the rock. So we probably want to do that. And that I think we'll do minus 90 so they're facing down towards me. But that still doesn't really solve at all this idea that the x coordinate is random and the y coordinate is fixed, and that the update method will actually update the y coordinate. Y minus speed times time. That's interesting, right? We reduce y by speed times time. And you ask yourself, why don't we see that happening live? Maybe we don't even need this rock.update 0 up here. Somehow the speed of the rock isn't really applying like you'd think it would. Or the updating the rock isn't really moving its model instance. Well, I wonder if I can print out like the rocks in their positions and see that they're moving or something. That might work. This is kind of like a simple test. Like checking that I'm not crazy. That's interesting. I really would have expected these rocks to be moving and flowing southward. I guess I didn't tell them to do their stand sequence yet. Maybe I need to do that, the random stand sequencer thing. Suppose the moving stand sequence would allow the rocks to actually fly at me. Oh yeah, okay. So I guess the rocks weren't updating their position when they weren't animating. That's kind of dumb. But, I guess it's better than nothing. So here you can see I now have my Phoenix Rock Dodger. Although we didn't really make... well, there's a couple things going on. The rocks are not continuing their stand looping. So we do want to say model instance set sequence loop mode to always, like we did in the other one. So that keeps those rocks, they're always spinning, they're always leaving behind a particle emitter. Other than that, they're not disappearing when they get off the screen. So I guess that's another thing, that basically if the rock has surpassed probably like minus 1,000 or something, we'd want to just delete it. And what does that look like? So I guess we probably could have like a destroy function on the rock, and one of the main things that's going to do is take the model instance of the rock and call detach on it, which detaches it from its given scene. It basically unloads the 3D instance of that rock so that it's no longer going to be there. And I guess this gets back to where if we have what is this? So if I have an iterator incoming, maybe just rock iterator, So yeah, basically this rock iterator next. Maybe this is where, oh yeah, okay. Iterator incoming rock. So this is an incoming rock, and then maybe I'll just call that rock, and then copy this rock updating thing, and then basically say if rock dot position dot y is less than negative 1,000, rock dot destroy, and then we're going to also take this rock iterator and actually remove the current element from it using that utility function that I didn't write, so that it'll actually delete the other variables of the rock out of its iterator where it's stored. Cool. So I think that means that it shouldn't like progressively lag more and more as things go on or whatever. But we've got our Phoenix rock dodger over here. And I think the next hardest part would basically be to say, if a Phoenix touches a rock, then print on the screen like you lose, blah, 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 or something like that. But I guess one of the things that seems nifty about this to me is mostly that this you can just put this to an executable like Warsmash. This isn't a Warcraft map, so I feel like that's kind of fun, and that's like, I don't know, that seems kind of fun to me. That like, why can't Warcraft 3 let you do that? Obviously, I'm not really very far along in my game because, as I started off saying when we started this project, the world gave me some alcohol, and now I made Phoenix Rock Dodger in a couple of minutes. But making Phoenix Rock Dodger is like the kind of thing that you should be able to do in a couple minutes. And honestly, I should probably make it that the Phoenix dies if it intersects. Like, I was trying to be really lazy and not do that, but it's not even hard. Think about it. It's not even hard. Like, you can literally just say, for all of these rocks, like I'm iterating the rocks, and I'll like destroy them if their position is whatever. There's another thing that you can do. Okay, and this other thing that you can do is basically to say, if rock.position.distance, what is it? Oh, no, they called it .dst. Okay, sure. Distance to the player position is less than or equal to 64 units. Basically, if you've hit this rock with about 64 units, then we're gonna do something similar to rock.destroy. But before we do that, I'm literally just gonna say, what is it? The sequence utils. Select sequence. What is it? Random sequence. Random death sequence. Here you go. Yeah, we can just say play the death sequence of the Phoenix model of your character, and also of this rock. And so the rock should like explode, like the rock's model instance, rock.model instance, and the Phoenix. And obviously the problem is I had this repeating thing. So let's set sequence loop mode to never loop after that. So that after it dies, it's just done. Just never loop. And we want to do that same never loop thing with the rock, so the rock doesn't like show back up again or something. So I think this means now I can actually die, which that's going to be kind of fun, but I'll probably die really fast because I can't see anything while the game's first loading. Oh yeah, there you go. Oh yeah, okay, so here's another thing. I think we need to have like a Boolean dead, you know, that just is like, did the player die? And if your player died, we're not going to keep playing that death animation because we only want to play it once. So basically, like, if not dead and all this other stuff, then dead equal true. And also, when we get to this dead state, all this stuff about player current move direction, this is like if not dead. So you can't move the player anymore once you're dead. That makes sense to me. Okay, great. I really wish we could cut down on load times and something, because that's, I gotta work on that. But yeah, there we go. Could I reduce the size of the window without dying? Nope, I died. That one killed me. It must have. Oh no, it didn't. I survived. Okay. See, and then it's suddenly like a challenge. You know, you try to see how long can my Phoenix survive, but you can get hit like that, and then you're dead, and then I can't move anymore because I died. And it's that same kind of programmableness that this is the Warsmash, man. This is why I kind of poke fun at people to say you could be free, okay? Because this concept, this isn't really the Warsmash concept. Like, I'm just using Ghost Wolf's viewer. This is the real deal. And the game of Warsmash is just a bunch of unit stat manipulation on this same engine. Look at this. This is just 250 lines of code, a little game, a Phoenix dodges some rocks. And I'm trying to tell you, you could do the same thing. You could do more. You could go beyond. And you could be the Phoenix next time. You know, like a Phoenix, like Immortality of Warcraft. And then my screen disappeared. But let's bring it back. So that's kind of my thinking. But don't drink alcohol. And I guess that about covers it. What was I going to do? Oh yeah, there was a system print line in here that was like printing out. I think it's in the rock. You probably don't really want that. That can actually slow down the game. That might have contributed to some of the lag from that. I guess another interesting thing you could do, if you're fed up with the problems I was having, you can stop setting the width and the height of your config. And that's more of actually LibGDX's default. So it defaults to this little 640 by 480 window, which is an interesting kind of thing. Obviously, this is very configurable, how you want it to do that. But this is kind of like what this one was doing. And it's obviously going to lag less if you have it in a little 640 by 480 window. I guess the other thing LibGDX likes to do is to believe that they can compile to a phone game. And so then you would say, okay, so I can make this, whatever this thing is here, I could make this into a phone game pretty quickly. But you'll find that that won't work because although LibGDX does that, the Warsmash, basically the port of Ghost Wolf's viewer, uses Retro Model Studio desktop-only loading code to load the art files from like Warcraft models. So it's not going to work on your phone. But it's physically feasible that you could change it so that it would, but I don't support that. Anyway, so this has been fun with LibGDX. I almost would feel wrong to even say this is Warsmash that we're playing with right here. Yeah, I just got my Phoenix killed for fun to show that the game was interactable. But yeah, it's almost like, is this even Warsmash? This is just the idea. This is just LibGDX. You know, this is just the freedom of building your own little game and putting Warcraft models and LibGDX as these two concepts. You know, like you make an MDX and you use LibGDX and you put them together and you get whatever you want, right? And it's that fundamental creativity that is why I was trying to tell people that Warsmash is an inspiration. It's a future of a liberated being. And when people try to compare that to freaking like some guy who's disassembling Warcraft 3 and trying to add reforged modding APIs into it, there is no comparison. They're not the same. They're not trying to do the same thing. They're not. It's unreasonable, okay? And maybe the world wants to say that this isn't Warsmash, and that Warsmash is the infinite and insane pursuit of the replication of Warcraft 3, but that's more of a joke. I think the technology novelty is LibGDX with 3D graphics, to be honest with you. And I was just intellectually lazy by loading Warcraft style graphics into LibGDX instead of just loading LibGDX's graphics with LibGDX's own 3D graphics libraries, which are basically the same as this. So if anybody's interested in this, one takeaway is, it's the Warsmash and the Ghost Wolf viewer. Those can get you MDX models, Warcraft models into this. But that's not really a good idea for the design of your game anyway. And in some sense, maybe it's all just that I was trying to prove a point and have some fun. But that's kind of my takeaway. And now I really have to sleep. So I appreciate the world and things and times. And I hope that you learned something. Thank you.